Hi folks, you are already familiar with the LTSpice GUI and toolbox. In this episode, we will simulate circuits with basic active elements like PN junction diode and Zener diode. We would explore diode characteristics with diode 1N914 using DC and temperature sweep. Then we will explore diode clamping circuit using SineWave input and transient analysis. Finally, we will explore voltage regulator circuit using Zener Diode 1N750 with DC sweep. So stay tuned, stay focused. Hey guys, welcome back. Today we'll be focusing on the active elements, specifically the diodes. We will see the IV characteristics of a regular diode. Then we will focus on a clamping circuit made by regular diodes, and then we will do the regulator circuit using Zener diode. So let us begin today's journey. So here is LTSpice icon. Let me double click it, and you can see the interface has opened. As I have mentioned in last episode that this is our marker pen app. So this is not a part of LTSpice. It was there. I use it to highlight different parts of the screen for your easy understanding. So here, first let me create a new file. So new schematic has been opened and it is in the draft stage. As you can see from this left top end, right? So we have to save it. So we'll go file, then save as, documents, then LTSpice. So here we are saving the circuit. Let me name it. We'll give the name as Diode Characteristics, and the extension will be ASC for the schematics. So let me save it. Now it is saved. You can see the name has changed in the topmost corner. We are working on a specific file. At the very beginning, you have to save the file so that you do not save it over and over the draft. Now let me draw the components. First, I will insert voltage component here. We place it. So there will be two voltage components. There will be first one here and then one somewhere here. Let me right click it and it goes vanish out. And simply there will be a diode. So again I will be going to the components and here let me type diode. Okay. And let me select the place icon and I have to place it. So I will place it here. I'll place it and I don't need any more diodes. I'll right click and it vanishes. So this is a very simple circuit. So let me rename it. This will be our DD and this is DX. We have named the two different sources, and here when I click right, so there is an option called pick the new diode. We will take the 1N914 type of diode. We go here, so you can see commonly used IN414, it is there, and here is the IN914. You can see it also has the model values here. So I'll pick the IN914, is diode model here. You can see the diode is there. I'll connect this one, and before that let me place the ground here. I'll now make the interconnection or wiring. Simply I will click here, move up to this point, click again, move up to this point, click here, come down, click at this diode E1 at the plus direction, that is the anode of the diode. And now I will click on the cathode of the diode and I will connect it with the voltage source plus. Then I will click here the bottom or the minus of the voltage source, click here. I'll drag up a horizontal line, click here at this grid, go up, click here and finish the wiring. So I need to connect the ground, so I'll click the ground and I'll connect it with the previous horizontal line. So now our circuit interconnection is done. So we have selected the diode type according to the various parameters are set there. So you don't need to tweak the parameters. This model is available in any LTSpice version, so you can pick it when you are doing the exercise using LTSpice. I will be using the different diode models because in real circuit, when you are designing an analog circuit, that time you have to pick up the components, and different components, how you will pick, you will go to their datasheet, and from there you will have the specification of that particular device. From there you can select their models. So that will help you to get a circuit which is desired, and all the components will be according to your basic calculation and specification that you have. Now I will specify the voltages here. Right, let me right click. Will have 0 value, 0 volt, and again here it will be 0 volt. Now here in this circuit we will do a DC sweep. So we will run a DC sweep of this voltage particular PD. Along with we will have multiple temperature levels, 1, 2, 3 temperature levels. So there will be a combination where in the x-axis the voltage will be varying this DC value, and y-axis we will have different graphs for different temperatures. That is our target. Now to introduce the DC sweep, right, I'll have to go to this particular spice directive command. I click here and I write .dc. Click OK and I place .dc here. And here when I right click, you see this value comes. Name of the first source here. We have given the name PD since we are sweeping the input voltage, right? The diode character. Type of the sweep will be linear. The start value will be 0. Top value will be 2 volt. And the increment will be 0.01 volt. So you can see here the DC syntax .dc syntax is getting created for the DC sweep. We'll have a DC sweep, along with we'll have a temperature sweep. I have already discussed these things in the earlier episodes. Please go ahead and go through those episodes where I have discussed. Now here our DC sweep is ready, so I'll click OK. So you can see our DC command is there, and now I will do again another spice syntax .temp, right? And for the temperature sweep, what I will do, I'll give the temperature values 50, 10, 100, 10, 150. Okay, so there will be 3 different temperatures. Again, for this .temp, I have already discussed in the previous episode about this syntax. Okay, go ahead and learn from there. Because when we are entering the LTSpice, we are at the application level. So here I will not discuss about the detail of this command, which I have already done in the earlier episode. Here I will click OK, and we will place this temperature sweep here. So here the x-axis will be the DC sweep. According to that, we will get the diode voltage, and different characteristics will be determined by different temperatures like this, this and this. This is the target. So here our circuit is done. Let me click the save button, and now I will run the simulation. So here I click on the run. So you can see the pin has come, right? Let me go here in the right hand side. Let me click here, hold it, drag it and release here. So you can see it is changing, right? Now let me click here, hold it, drag it and release it here. Add hot pen below the active. So let me use the delete. Click visible traces. So here I will click the ID which is of the diode D1. Click OK. So you can see we have 3 different traces here in the ID for the 3 different temperatures. So here I have removed the above one and it escaped. So here you can see here in this axis this is voltage. We are doing the voltage sweep. Here in this axis we have current, and we have 3 different curves, 1, 2 and because of the 3 different temperatures we are getting the 3 different curves. That is the characteristics. Now I will go dot settings and I will go to dot pin below the active pin. And here if I this circuit, right, if I click here in the current, right, so again you can see the same thing is coming. So either you can go up to this, pick visible traces, from there you can pick the diode current, that is through D1, or you can go ahead here when this symbol comes you click if course. This is how you can have these characters, and both are same, both are giving for ID1. Let me hit and it comes the cut. So here, but this will be the single thing that will be passing, and this is how you can see voltage across this diode, which is varying in the axis, and the current diode varying, and these three different traces are from the temperature. So let me close it, and here we are done with the diode characteristics. It was a very easy and simple circuit, and this was your first active element circuit that is drawn by the schematics, and then we have analyzed using SPICE. Okay, before going further, I will expand it and I'll check one thing that I have done in last episode also. I'll go view and see the SPICE output log. So you can see here that there was no error, and here you can see temperatures are, CPU thread is 8 and it has completed, right? And we go and view the SPICE netlist. Here you will see that we have used the diode model, right? That diode model has been included automatically by the LTSpice from the SPICE lib. So from this lib, the diode definition, that is diode 1N914, is coming here. And also you can see that we have a DC sweep here, we have a temperature sweep here, and we have diode instance here and 2 volt. That's a very simple circuit, and that is how you can also cross check the SPICE netlist so that to understand what is happening underneath. You have already learned the SPICE, so this will be very easy for you. It's done. I'll close it and I'll save the file before closing, and I'll close it. So here at this point we are done with the first active circuit, and we will move on to the second active circuit using the diode. So here let me first open a new file. Here the new file is there. We will have to go file and save as, and here we will name it Diode Clamping circuit, and the extension will be schematics, that is ASC. Then we will click save to save the file. As you can see here, the name comes of the file Diode Clamping circuit. Now comes the part when I will assemble the different components here in the dashboard of the schematic. So here first let me go here, hit voltage. Here it is. I have selected the voltage. Let me place it. So there again will be 2 voltages. One will be here, another one will here. 2 voltages will be there, one with the diode, and here let me click to vanish. Now need a capacitor, and from keyboard I need to place it horizontally. So I'll click Ctrl R. So it has rotated, so I'll click it here, and I don't need any more capacitor, so I'll right click, it goes vanish. I need one resistor, so I'll pick the resistor, and it is in the vertical mode. Here I will place the resistor, and it's done. Let me right click and it vanishes. So I'm assembling the components on the dashboard. Like when you create a circuit on the breadboard, you pick up and place the different components, and then you make the vary. Similar is here. So here next I'll pick a diode. So this will be a simple diode, and I have to rotate it, place it. So I'll place the diode now. So all the components have been placed. One more remaining, that is the ground. Place the ground here, and now let me do the pairing. Here I click here, I go up to the point, and here click at this point, go up to this point, click downwards. Here I click. So the connectivity of the capacitance and the diode has been done. Here click, connect it, and here I click at the negative or the value of the voltage. I click here, I move horizontally and come up to this point of the axis where the grid is vertically pointing towards the negative of V1. Here I click, go upwards. Here I click and finish. Let me connect the R here, top line. Click, and here the ground is remaining, so I'll click the ground here. Done. Now comes the part. I'll specify different edges and values. First I look here. Here this will be a DC value. So the DC value will be 5 volt. It will be a 5 volt. For the capacitance 1 micro. For the resistors it will be 1 meg. The diode is simple a diode, so I will not do anything with it. It will remain as is. here in the voltage, here I will specify this as, and click here and I go to advanced. Here I will apply a sine wave. Whose DC offset will be 0, the amplitude will be 10, frequency will be 1 kilohertz, and there will be nothing here. This will remain empty. You can see I have selected the sine, then given the offset 0, amplitude 10 and frequency 1K. Here I have specified nothing. Here I have specified nothing, and it is gray, so is also not here. Now I will click OK. It is a sine wave, and here let me click go to advanced. In contrast, you will see here, right here, nothing is selected. Nothing is selected here. Is not selected. This is selected. Only the DC value is there, 5 volt. So this is for VT. Now this is done. Here what will happen, we will do a transient analysis. So I have to insert the dot tran command. I take the spice directive and here I write dot tran, place it, and then I right click on it. So here immediately it opens up a transient dialog. Here I will mention the stop time, that is the millisecond will be stop time. Start time to save data, that means we'll start it from 0th time. And here the time step we have to mention, that is 20 microseconds. So you can see that we are doing the transient analysis. Here the spice command is getting constructed. We have given the stop time as 3 milliseconds. That means we'll finish line is 3 millisecond. Start line is 0 here. And at steps will be, at each step, that will be 20 microsecond step. So from one point to another point, there will be a jump of 20 microseconds. So we'll get points separated by 20 microseconds. They are done the specifying. Let me click OK, and you can see this is modified already. So I have done a zoom out so that we can see the all together the circuit. So let me save by using save button, save the circuit. Let me point out what we have jotted down so far. So we have specified a voltage with sine wave. We have a 1 micro capacitor, that is microfarad. You cannot see the unit, right? Resistance is 1 meg and the unit will be ohm. Voltage is 5 volt here. Diode is our regular diode. Okay. And that's the setup. So we are running a transient here. We will be doing the transient analysis of this diode clamping circuit. And obviously we will be measuring the output across this one. This is basically the load rate. We are done here. Let me run the circuit. Before that, let me view SpiceNet. Here you can see the diode module has been picked up from here. Diode is here, resistance is here, capacitance is here, voltage 2 is here, voltage 1 is here. And we have a dot tran here. So everything is there to put for the spice deck. Click here and close it. So here now we'll do a run. And here you can see this has come. So first we'll go view the spice output log. And as you can see, you don't find any errors there. So temperature is 27 and has finished. It has used 8 CPU threads. It's all good. Now let me close it. And now what I will see that first let me 2 panes here. Go to simulation, plot settings. Add a plot below the active pane. So we'll have 2 panes. So in the first pane, I click and select. Go in the circuit. I click, hold, drag and release. One is the first one. Then I click here. Then I go to this pane. Again, I click, hold, drag and release. So you can see. And let me inspect more. So let me go plot settings. And let me go here. I click here, hold, drag and release. Now if I drag and drop here, right, this will look like this. You can see if I hit the del and cut it, so you can see all the 3 different voltages together. So this is the output of the clamping circuit. Click, hold, drag, release. And if I go to the peak visible traces, right, and from here, if I go for IC1, BBC1, ID1, since these are coming, right? So plot settings, go in below, right? Here, let me check what are going inside. One, I for that. So if I hit V, it adds a pane below. That is much more easier than this. So click here on R1. So 3 different currents are there. I think we are done with the analysis of the circuit. Here I'll close it. I'll save it before closing. We're done here. Let's close the circuit. Now here we are having the blank canvas again. Now here we will move to the next section where we will construct a Zener regulator circuit using 2 Zener diodes of type 1N750. Let me start it with clicking the new circuit. So here I will go to the file, save as, and here I will save it as Zener regulator circuit. And the extension will be ASC, that is the schematics. So I'll save it. Now let me show you that we have the file name coming in the topmost left corner here as a Zener regulator circuit. So we are working on a file and we are not saving it as a regular draft file. And now here is the dashboard for creating the schematic. We have the dashboard here. So let me assemble one by one the components. First, here I type and we have the voltage. So let me click it. Is the voltage here. Will not be needing any more voltage, so I right click and vanish it. Now we need 2 resistors, one is in series, one is as load. First let me hit the Ctrl R, so it will act as a series resistor, and let me do the R, and this will act as a load resistor. Yes, I don't need any more resistors, so I'll right click and it will be. Let me go to the save button and save the circuits. I'll need to Zener diode. So here, go to the components. Here I'll go and search for the Zener diode. Here you can see there is a Zener. Starts with Z, so alphabetically it is in the last. Let me click and place it. The first one will be faced downwards. And now let me click Ctrl R twice. The second diode will be facing upwards. And I don't need any more diodes, so I'll right click. Now comes the part when I place the ground here. Right click, the ground vanishes. Now comes the wiring part. So every component has been now spread over our dashboard, or you can call it a virtual breadboard. Now I will use the wire to connect them. First I'll click here, go upwards, click, then move right and click and finish the wiring. Then here I'll click, move up to this point, click, come downwards, finish here. Again I'll click here, go downwards, click here, move horizontally up to this point, click here, go up and click here. The voltages are connected with the resistors. Now comes the diode part. Let me click here. Following the grid, I click here, connection is done. Let me pick cathodes of the diodes here, done. Now here the anode, let me connect it horizontal line. Now let me connect the ground with, so the wiring is done. We do a zoom out that we can see the circuit perfectly okay to see everything. Now something is remaining. We have done the placeholders. I have to suggest the exact values. So first, right click here, we'll give a 0 value here, as we'll be giving a DC sweep. So initially I will keep it 0, then we will have a DC sweep on this. Now comes the resistor. I'll click here, the resistance value will be 500 ohms. Now I click on the Zener and pick a new diode. Here you can see different diodes are there. We'll have to use the 1N750. Here is the 750, which has a breakdown voltage of 4.7. So this is the reason of picking up 750, because we want to have a voltage of 4.7 breakdown. How you can select the Zener, right? There are multiple Zeners here, and here is the breakdown voltage. So for our circuit, we will be picking up 4.7. So you have to pick up the 1N750. If you need something else, some other voltages, you have to pick from the list. So let me select the 1N750, click OK. In the similar fashion, I'll right click and here I'll go to pick new diode and here I'll scroll down and again here it is Zener that is having this 4.7 breakdown voltage as 1 in 750. You can see two Zener diodes with 4.7 breakdown voltage are selected. Now I'll click save. One more resistance remaining here. We will go here and click 1K. So it will have 1 kilo ohms, the load resistance. So here let me click this button for saving this circuit. Now we will add a SPICE syntax called .op here. Next we'll have the DC sweep. For that I will have to write the .DC. Click it here and now we have to add the sweep. So I'll right click and the corresponding dialog box open up. So you can see we are using the DC sweep. Earlier we have used the AC, transient, etc. Okay, and now the name here. So this is V1 because we will be sweeping this voltage. We are giving this particular name here. Type of the sweep, this will be linear. Now comes the most important factor, at what value we will start, because we are tracking with a Zener, right? The voltage tracing will be on the Zener and we have to back Zener diodes. The range will be much higher than 4.7. Here we start with minus 15, top value is plus 15 and we will increment using a step called 0.5 volt. As I type the values, you can see this SPICE syntax is getting created. So this will be the SPICE syntax. We have talked about this SPICE syntax in the SPICE syntax episode before starting the LTSpice. Go ahead, learn from there about the details of these things, and also you can learn from this GUI. Here I am giving the purpose details, right? The source is V1, type is linear, start value is minus 15, stop value is 15, and the step or the incremental step, that is 0.054. So let me close it. Now I'll click OK and you can see that the DC sweep have been defined here. Now comes the most important part. Let me save it first and then we go view to the SPICE netlist. Here you can see that this OP has been auto-commented by LTSpice because of the SPICE methodology, right? And here we can see the DC sweep is here, right? Also you can see the diode has been picked up from this particular library. Also you can see two different diodes of type 1 and 750 is here. Resistance, second resistance and the first resistance here, and the first voltage source is. So our SPICE deck is there, ready to be analyzed. Now let me pick it, save it and run the simulation. Now we have done the simulation, so I will check the response of this particular current, right? So you can see that when I click the current from this load resistance, right? So when I click for the load resistance current, right? The current that is going through, it actually represents what is happening in the back-to-back to Zener diode. It's a voltage regulator circuit. You can see here is the voltage. Voltage is the independent axis. So here 2 points of the breakdown, and which is approximately almost here around breakdown voltage of each of them, and you can see. So here we have done the Zener characteristics, and if we want to explore more things, can explore. Let me hit B and add a pane below, and here the D1 current from D1, you will see it like that. Okay, and again get me a pane below and let me bring the traces, and D2 current will be like. So we have two different kinds of characteristics of the currents here. So we have done the Zener clamping characteristics. Want to explore and go ahead further, and you can analyze all the voltages and currents that are coming for this particular circuit. Let me click OK and we are done here. So let me close this plot and the circuit. Let me click here and let me go to view and SPICE output. There were no errors, as you can see. We have used 8 threads here on the CPU. Temperature was 20. We are done here with all of the 3 circuits that we have explored today. Diode characteristics, diode clamping circuit and Zener regulators. And that's all for today. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.